Fat. Yes, fat is an organ. Often dismissed as a passive energy reserve or blamed on laziness. Fat is a highly active endocrine organ crucial for health. It produces hormones, cytokines, and bioactive molecules that regulate metabolism, immunity, reproduction, and even brain function. Yet when fat accumulates excessively, it becomes a major driver of chronic disease and premature mortality. For millions of years, humans evolved under conditions of intermittent food scarcity. Natural selection favored efficient energy storage and metabolic thrift. Our bodies evolved to store every available calorie as triglycerides in adipocytes. Modern society, however, presents a paradox. Abundant, hyperpalatable, ultra-processed food combined with sedentary lifestyles. Foods high in sugar, refined carbohydrates, and industrial fats hijack our reward pathways, releasing dopamine and reinforcing overconsumption. This leads to chronic positive energy balance, especially when combined with stress and poor sleep. Two factors that dysregulate appetite hormones. Marketing, particularly toward children, further reinforces early life overeating behaviors. The result, obesity rates have skyrocketed worldwide, now surpassing rates of malnutrition in many regions. Adipose tissue is composed of adipocytes, stromal cells, immune cells, and a vascular network. There are two primary types of white adipose tissue. Subcutaneous fat, located under the skin, functions mainly as insulation and energy storage. And visceral fat, which surrounds internal organs, is metabolically active and hormonally aggressive. Fat communicates via adipokines, hormones, and signaling molecules that influence distant tissues. Leptin signals satiety to the hypothalamus and regulates energy expenditure. Adiponectin improves insulin sensitivity and reduces inflammation. Resisting is implicated in insulin resistance. Pro-inflammatory cytokines, including TNF-alpha, IL-6, and MCP-1, recruit immune cells and modulate systemic inflammation. When fat mass is excessive, these adipokines become dysregulated, creating systemic metabolic dysfunction. Visceral fat is particularly dangerous due to its proximity to vital organs and its high metabolic activity. It responds strongly to catecholamines and cortisol. During stress, it releases free fatty acids into the portal circulation, directly affecting the liver. Continuous signaling alters insulin, leptin, and sex hormone function. Individuals with abdominal obesity, apple-shaped, have higher risks for metabolic syndrome compared to gluteofemoral, pear-shaped fat, which is relatively protective. As adipocytes expand, they outgrow their blood supply, creating local hypoxia. Hypoxia triggers HIF-1 alpha activation, leading to fibrosis, oxidative stress, and apoptosis. Dead or stressed adipocytes release damage-associated molecular patterns. Macrophages infiltrate and form crown-like structures around dying adipocytes. Chronic low-grade inflammation results, with circulating cytokines damaging endothelial cells and other organs. Free fatty acids and pro-inflammatory cytokines impair insulin receptor signaling via serine phosphorylation of IRS1. Muscle and liver cells uptake glucose inefficiently, raising blood glucose and prompting compensatory hyperinsulinemia. Chronic insulin resistance can progress to type 2 diabetes. Excess free fatty acids lead to ectopic fat deposition in the liver, pancreas, heart, and skeletal muscle. Lipotoxicity damages organ function and contributes to cardiovascular disease. Hormonal disruption occurs as well. Leptin resistance develops, so the hypothalamus no longer receives the enough energy signal. Aromatase activity in adipose tissue converts testosterone to estrogen, lowering testosterone in men and increasing estrogen in women, which raises breast cancer risk. Chronic stress and cortisol amplify fat accumulation and metabolic dysfunction. The toxic effects of excess fat are systemic. Cardiovascular effects include endothelial dysfunction, atherosclerosis, hypertension, and increased risk of heart attack and stroke. Metabolic effects include insulin resistance, hyperglycemia, type 2 diabetes, and non-alcoholic fatty liver disease. Renal effects include hyperfiltration and increased risk of chronic kidney disease. Neurological effects include cognitive impairment, depression, and increased risk of Alzheimer's disease. Musculoskeletal effects include osteoarthritis, joint pain, and reduced mobility. Immune effects include impaired pathogen response and delayed wound healing. Excess fat also increases cancer risk through chronic inflammation producing reactive oxygen species and DNA damage. Dysregulated insulin and IGF-1 signaling promoting cellular proliferation. Altered sex hormone metabolism, and adipoke imbalance enhancing tumor growth. Currently, around 10% of cancers in the United States are directly linked to obesity. Obese cancer patients also have poorer outcomes. The good news is that adipose tissue toxicity is largely reversible. Weight loss through diet and exercise reduces inflammation, declines macrophage infiltration, normalizes adipokine profiles, and improves insulin sensitivity as muscle and liver cells regain glucose uptake ability. Hormone levels, including leptin, testosterone, estrogen, and cortisol, stabilize. Cardiovascular risk decreases with improvements in blood pressure, cholesterol, and endothelial function. Even in established type 2 diabetes, significant fat reduction can restore glycemic control and metabolic health.